Cyclic events. In many parts of Nigeria, markets are held in rotation, as like in circular form. Some markets are held every third day, others are held every fifth day, and so on. In one region, 4 markets A, B, C, D are held every fifth day. The table below shows some days of the week in a month when each market was held. Now, the circle below shows that the markets are held in a circle. This is an example of a cyclic event. Like each day, from what we have here, we're told that each market is held every fifth day. So if it starts with market A, 5 days afterwards, market B will be held. 5 days afterwards, market C will be held, and then D after 5 days, back to A after 5 days, back to B after 5 days. So it's in a rotational form, which is a cyclic event. So this is an example of a cyclic event. The numbers 0, 1, 2, 3 may be used as codes for the markets B, C, D, and E as shown in the table below. So I want to assign market B with the code O, I want to assign market C, I want to assign the code 1 to market C, I want to assign 2 to the market D, I want to assign code 3 to market A. So if you do that, you replace these letters with the code. Here you have B, you put 0, C, you put 1, D, 2, and A, 3. You're going to have this here. So if you rotate, you're still going to, if you start at A, that means you're going to start at 3, and then still be in a circular form. So with that, let's take an example. So by completing the table, which is this table, is not completed, we have empty columns, empty boxes that needs to be filled. So by completing the table, find which market is held on a Tuesday of the 4th week. Tuesday of the 4th week, which is here, and A Tuesday of the 4th week, and B Thursday of the 1st week. Thursday of the 1st week. So how do we fill up this table? We proceed by using number code. So let me do our calculation here. So this is our number code. 0, 0. Okay, so this is 0, 1, 2, 0. The question says now, the explanation here is that in one region, 4 markets A, B, C, D are held every fifth day. So between B and C, there's an interval of 4 days. That's implication. So from between A and B, A is held, and then when B is held, there was an interval of 4 days. So after B, there was 4 days before market C was held. So we're going to be rotating to fill up this table. So Sunday, which is the first day of the week, we start from 0 to 1. This is the first day of the week. And the first market will be held on 1, and 1 is C. So start with C. So it indicates that movement which is movement from 0 to 1. 0 to 1. So the next market day, which is Monday, will be 4 days after. So 4 days after, rotate, that will be 2. So that will give us B. 2 is D. The next one will be to move from 1 to 2, 2 to 3. 3 is from another code. 3 is E. So rotate again from 3 to 0, which is the next market day, which is from here to here is 4 days after. So from here to here is 0. 3 to 0 is B. The next market day will be to rotate to 1 and C. So we can fill this of C, D, E. So A, B, B is 0. So the next market day will be from 0 to 1, rotate from 0 to 1, that's 1 is C. And then from C, the next market day will be what? D. From 1 to 2 will be D. Then from 2 to 3 is E. 3 to 0 is B. 0 to 1 is C. 1 to 2 is D. 2 to 3 is A. And 3 to 0 is B. By so doing, we have filled up the table. So let's answer our question. Solution. E. By completing the table, find which market is held on a Tuesday of the 4th week. The 4th week is this row. Tuesday of that week is B. So the market that was held, or the market that is held on Tuesday, okay, let's see. Market B is held on Tuesday of the fourth week. B is Thursday of the first week. Market C. Market C is held on Thursday of the first week. So those are the answers to our example. By using the completed table, which is this table here, find the days on which A market B is held in the 4th week, B market A is held in the 1st week. That's the solution. A market B is held in the 4th week. So let's go to the 4th week. Market B is held 2 times in the 4th week. So D, which is on Sunday and Thursday. Market B is held on Sunday and Thursday of the 4th week. Market A is held in the 1st week. Market A is the 1st week. Market A is held on Tuesday and Saturday. Market A is held on Tuesday and Saturday of the first week. Using the number circle above, which is this number circle, find A. Find A. Which market was held 7 days after market B? A. 7 days after market B will be 7 days after market B. So market B has the code 0. I'm going to rotate 7 times. This is 1, 2, 3, 4, 5, 6, 7. That's 3. And it's market E. Market E is held 7 days after market B. Another way to represent this is 0, which is market B. 0 plus 7 3. What this implies is that 0 is market stands for anywhere using number code, and this code stands for the letters representing each of the markets. So 0 is market B. So plus means you rotate or move on this circle 7 times, and when you're going to stop after you return 7 times is 3, or the number you're going to stop at is 3. So if you start at 0, which is market B, and 7 days after market B would be 1, 2, 3, 4, 5, 6, 7. So that's what plus 7 means turn around, a forward movement, or in the clockwise direction, make a clockwise movement 7 times. So the 7th time, or the 7th turn, is going to be 3, and 3 stands for the code E, so which is market A is held 7 days after market B. Which market was held 10 days after market D? D code is 2, so we're going to rotate 10 times on market D, which is 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Market 10 is B. Market E, market B is held 10 days after market D. So using our number codes, we can also simplify this to say 2 plus 2 modulus market D is 0. 2 plus 10 is equal to 0. So what this implies is that the question says we use number code, use number circle above, and the number circle is the number code for each of the markets. So 2 here represents market D. So after 10 days after market D, that's what is plus 10 means. From market D, which is the reference market D, rotate 10 times to where that rotation stops or ends. That market D is going to give us the day that particular market is going to be held 10 days after. So 2 plus 10, start at market D, which is 2, and then rotate 10 times, and then we can start at market 0, code 0, which is for market B. So market B is held 10 days after market D. When using the number circle as shown below, we can see that adding 4s has no real effect. This part is our last example. We use number circle, number code, and there was something that looks like this when I explained that 0 plus 2 implies, and I told you that 0 means where you are starting, 2 means your movement forward 2 times. So you have 1, 2. So 0 plus 2 will give you what? 2. So it looks like addition, 0 plus 2, but if it's addition, 0 plus 2 is 2, that's correct. But if it's let's say 0 plus 1 plus 2, what will it imply? It implies that start at 1, our reference is 1, move 2 times from 1. So this is 1, 2, this is 3. It's correct. But once it gets to 4, let's say 1 plus 3, 4, and let's say 1 plus 5. Let's see what 1 plus 5 will give us. So start at 1, move around the circle 5 times. So this is 1, 2, 3, 1, 2, 3, 4, 5. 1 plus 5 is 1. So look at this instance. So you can see that 1 plus 5 in addition is 6, but here 1 plus 5 is 1. So what does it tell you? So it says that we are not really doing addition here. It's just we are using this to represent what we are doing practically. This 1 plus 5 has a meaning that is different from 1 plus 5 when we are doing addition, which is equal to 6. And the deal of this is what modular arithmetic is all about, the mathematics of remainder. So I will get to that. When I get to that point, I will explain what that means. So when using the number circle as shown below, which is this number circle, we can see that adding 4 has no real effect. 0 plus 4 is equal to 0, or implies that the answer is 0. Now, 0 plus 4 is 0, but now 0 plus 4 is 0. What does it mean? It seems like if it's addition, this is not correct, but if it's modular arithmetic, this is correct. And this is what we mean. 0 here from the number cycle means start from 0, and therefore plus means move forward. There are instances where you can have 0 minus 4. This minus indicates that you move backwards, but now we are looking at plus 4. So 0 plus 4, it means start at 0, move around the circle 4 times. Where you stop, the 4th rotation, or the 4th time, or the 4th turn where you stop will be your answer. So if you start at 0 and you move 4 times, you're going to stop at 0. That's what it implies. So 0, this is 1, 2, 3, 4. You get it? So that's why we have implies 0. 1 plus 4, start at 1, move 4 times. So start at 1, 1, 2, 3, 4. It gets to 1. 2 means start at 2. The plus means move forward. Take the clockwise movement. Forward movement means clockwise movement. Minus means anti-clockwise. So 1 or 2 plus 4. Start at 2 and then move 4 times. That's making a clockwise turn. So 2, 1, 2, 3, 4. We get to 3. Same thing. Start at 3. Make a clockwise turn. 1, 2, 3, 4. So you see that all of these things are not really addition, so to say, because 3 plus 4 gives us 7, but 3 plus 4 in modular arithmetic is 3. And so this addition representation means something different from what addition means in arithmetic. Okay, so similarly, adding multiples of 4 has no effect. 0 plus 8 means start at 0. Plus means make a clockwise turn 8 times. Where you stop is going to be the answer to 0 plus 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, which is 0. 1 plus 12, start at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Get at 1. 2, start at 2. You rotate 20 times, or making a clockwise turn for 20 times by starting from 2. You're still going to arrive at 2. That's what it implies. So a short way to find, instead of this continuous rotation, like if you say 3, start at 3 plus 40, it's going to take you a long time to rotate, count. This is like what kindergarten children do. We give them 44 plus 6. So first of all, count 44, 1, 2, 3, 4, 5, 6, and then count 6, 1, 2, 3, then add it together, 1, 2, 3, 4, 5. That's what when you are starting, that's the way you start. But now we are advancing, so we don't need to keep rotating around the number circle. So what we do is we adopt another method. So a short way to find the final result of addition like this is to divide the sum by 4 and write down the remainder. So in example 3, actually initially that's this thing, what we have here is about modular arithmetic, and modular arithmetic, so the same is the mathematics of remainders. So that's what we're going to do. This is like an introduction to modular arithmetic. So for instance, in our last example, we looked at 0 plus 7, which is 7, and then remainder 3, 2 plus 10, 0. So let's look at, okay, following from, okay, so 0 plus 7 means if you have to use this number circle, it means that you have to start at 0 and move or take a clockwise turn 7 times. So this will give us 1, 2, 3, 4, 5, 6, 7. We're going to stop at 3. So what do we have here as a final answer? 3. But if you don't want to turn like this, like what the statement here says, simply divide the sum by 4 and write down the remainder. Why 4, you may want to ask? Because the total number of figures we have here, we have four different points of reference: 1, 2, 3, 4. And that's since it's 4, this is mod 5 in mod 5. And a thing about modular arithmetic is that the mod of a particular number is, if you are looking at calculations in mod 5, the highest number will be 4. If you are looking at calculations in mod 6, the highest number would be mod 6 will be 5. So it's just a difference of 1. It's simply with binary numbers, where you have binary base 6, the highest number is 5, base 7, the highest number is 6, base 8, the highest number is 7, like that. So this is done in mod 5. So the highest number is 4. So we have 4 references here. So we're going to divide by 4. So 7 divided by 4 is 1 remainder theory. Since modular arithmetic is the mathematics of remainder, you always take the remainder. So 7 divided by 4. I mean, 4, you have beside 7, you have 1. And then there will be theory remaining. So which implies in modular arithmetic, 7 divided by 4 is equal to 3, not 1. So we only take the remainder, not 1. So 7 divided by 4 implies 1 remainder theory, which implies 3. So our final answer was 0 plus 7 is equal to 3, or 2 plus 10 is equal to 12. When you add 0 plus 7 is equal to 7, 2 plus 10 is equal to 12. Now divide 12 by 4. 12 divided by 4 is 3, remainder 0. So implies 3, remainder 0. So our answer is the remainder, which is 0. Or briefly, 0 plus 7 is equal to 0 plus 3. Where is this 3 coming from? It's from this 7. 0 plus 7 is 7. You divide the 7 by 4. 7 divided by 4 is equal to 1 remainder 3. So this 3 will take the place of 7 here. So 0 plus 3, and then you do the addition from here. Instead of doing the addition from here, first of all, then divide by 4. You could first of all do the division here. Use this number to divide by 4. The remainder added to 0. So 0 plus 3 is equals to 2, which is the same thing as what you have here. Same thing here, 2 plus 10. Instead of adding first and then dividing, you could just, since this one is less than the mod number that the number we are carrying the modular arithmetic operation on, we are carrying that modular arithmetic operation on mod 5. So the highest number is supposed to be 4, but now that it's 10 and it's bigger than 4, we're going to divide the bigger number by the number on which we're carrying the operation on, which is mod 5. And mod 5, the highest number is 4. So 10 divided by 4 will give us 2. 2 plus 10 divided by 4 is equal to 2 remainder. 4 times 2 is 8 remainder 2. So this 2 remainder is what you are going to put here. So 2 plus 2. Now 2 plus 2, this is when you carry out your addition. So 2 plus 2 is equal to 4. Now you are carrying out your addition. Your in mod 4, the highest number is 4. So this can also read. So 4 divided by 4 is equal to 1 remainder 0. So this is what we are going to take here. So 4, our answer will be 0. So that's why 2 plus 10, 2 plus 2, applying 0. Okay, or you can come here and say 0 plus 7 is equivalent to 3. Either you use this method to get 3 as a final result, or use this method to get the final result, which is 3. But instead of going through this long process, after you've done this on a separate place, you can say 0 plus 7 implies 3, 2 plus 10 implies 0, or it's equivalent to 0, where this sign means it's equivalent. So this is a short way of representing. Instead of taking clockwise sum every now and then, you can just add them up, divide by 4 and get the remainder, or divide the number that is bigger than the number on which the modular arithmetic operation is carried out. In this case, which is mod 4, 7 is greater than mod 4, so you divide 7 by 4. The remainder added to this is one that's already less than 4. This one is less than 4. So this one is bigger than 4, this one is bigger than 4, and you're carrying out this addition in mod 5. So which means divide by 4, the answer added to this. If it's still up to 4, greater than 4, you divide again until you get a figure less than 4 or less than 5. So then from here we'll be going to modular arithmetic properly. We're looking at addition, multiplication, subtraction, and then division, and also equation.